So n means the number of samples you took, okay? And right up here it says samples, in other words, synonymous with that, and statistics is observations. There was 100 data points that were obtained. The number passed, they tell us, is 80. The sample proportion, you can calculate that real quick. There was 80 successes out of 100 people. So that's 0.8 that needs to go here for the sample proportion. Let's see, P. Oh, do they mean p-value? Because we don't know the true population proportion. I'm struggling because I don't know if they mean p-value or if they mean the population proportion. Since I'm going to take them for their word, they said p, I'm going to double check after this video. The true proportion, you know, this is missing the hat, right? The true proportion is 0.75. So that's a little bit of notation difference there. The sample proportion is what you get when you go out and you actually calculate the data numbers. We calculate 0.8 for our sample proportion down here. The population proportion we're testing it against is 0.75. I'm pretty sure that's what they mean. I think Zybooks would know enough to write p-value here to avoid the confusion. I wasn't sure if they wanted p-value or the population proportion, but I'll double check after this video, make sure I don't lead anybody astray. And to calculate the z-test statistic, you take the sample proportion and subtract it by the population proportion that you think it is, and then it's this in the denominator, 1 minus p over n. And you should see a similarity to the z-score formulas we've used before. Test value subtracted by target value divided by the standard error. So we got 0.8 minus 0.75, and that's divided by the square root of 0.75, 1 minus 0.75 over n, the sample size of 100. So the top part of the z-score formula is easy, right? 0.8 minus 0.75, just have to type that in a calculator. So that's 0.05 in the top. Watch what I do in the bottom now. I'm going to do 1 minus 0.75 first. And then that's a parentheses written next to this number, so I'm going to multiply by 0.75. And then I'm going to divide by 100. And then I'm going to take the square root like it tells me to. It's the square root of the whole thing. You got to divide by 100 first before you take the square root. So I'm going to take a bunch of decimals with me to make sure I make Zybooks happy. Well, it won't let me. Okay, well, I'll just write it out. 0.043. 30. Okay, I'll just stop there. 0.0433. Because the last step is to take the numerator, the 0.05 that's in the top of the fraction, divide by the denominator. So I got a z-score of 1.15. It's not a negative sign. It's 1.1547. I don't think it says how many decimal places, so I'm just going to write 1.1547. That's our z-score. Hey, so like I said, I checked. This is really confusing notation. Zybooks should definitely change this. They need to be more clear. This is the p-value. That's why I thought, because it's pointing to this tail, but, you know, p and p-value mean two different things in statistics. They should say p-value here. So this is 0.124. They wanted the p-value, not the population proportion that we were talking about. So just watch out for that when you do your problem. So go ahead and pause if you haven't seen this one yet, but an airline would like information on which seat is preferred by customers. Majority prefer the window seat, looking for evidence to support this claim. So they're asking people, do you prefer the window seat, yes or no? Okay. So the population parameter that we want to choose, I don't have the drop-down menu here, but the parameter that you're trying to estimate is, I can't type it. It's the population proportion of adults. It's the proportion of all adults that prefer the window seat. So ignore anything about a sample. It's about the population proportion of adults that prefer the window seat. So what condition is met? Let me get the drop-down menu. I pushed a button. Okay. So for this 7.1.2, for the second part of it, Go ahead and pause if you haven't read through, but a population parameter is always talking about all the numbers of the population. So it's all customers who prefer, nothing to do with the sample when you talk about a parameter. What's a condition for using a Z distribution? Just like in a previous video, got to have more than 30. It doesn't have to be just from a simple random sample. You could do stratified sampling, and that would be fine. Okay. True population proportion is known. That's almost never the case. So. What's the level of significance? So it's a 95% confidence interval. So we're assuming that they want 0.05 for a level of significance. Really, though, they should just state it because that's something humans choose. You shouldn't be just looking at a confidence level and trying to interpret. Plus, 0.05 should be for a two-sided confidence. Either way, I won't go into the spiel. I think I'm going to have to click the button for Zybooks and give feedback because I'm not sure if it's supposed to be 0.05. I think it's supposed to be 0.025. But the null hypothesis. Okay, what's the null hypothesis? The airline assumes the majority of customers prefer the window seat, and they're looking to support that claim. The airline thinks the proportion for window seat is greater than 0.5, meaning a majority. So that's your alternative hypothesis. The alternative is always the hypothesis you're trying to test. And the null just means that it's equal to what their original claim was, that there's no effect happening. So the null hypothesis, there's no effect, that it is equal to 0.5, there's no difference. The alternative is that it's greater than 0.5. So should we reject? They already give us the p-value. The p-value is less than the level of significance, so we reject HO. And the conclusion is that there's sufficient evidence for their claim.